In this video, I want to take a look at exam revision for indices. So as always here, all we're going to do is just take a look at some exam style questions for indices. What I would recommend is that you pause the video, have a look at the questions as they appear, and double check that your solution matches what we get on the screen. So other than that, that's everything that we need here to get us started. Let's begin then with question 1. Let's begin here with part A. We're asked to simplify x to the power of 4 times x to the power of 5. So all I'm going to do here to begin with is just write down this expression here. So x to the power of 4 times x to the power of 5. So because they share the same base here, so we've both got a base of x, so x to the power of 4 times x to the power of 5. In this case then, when we multiply these together, we simply add the powers. That's what the laws of indices state. So in this case then, we're going to get x here to the power of 4 plus 5. And if we simplify this here, we get x to the power of 9. 4 plus 5 gives us 9. And there we have it. So x to the power of 9 there is the solution to A. If we take a look at B now. And again, I'll just begin here by writing down the expression. Got y to the power of 7 over y to the power of 6. So again, they share the same base here. So we want to simplify this here. Again, we're just using the laws of indices. But in this case now, because they share the same base, we subtract the powers. So in this case, I'm going to get y to the power of 7 minus 6. And 7 minus 6 would give us 1. So we get y to the power of 1. But remember, we don't need to write this power of 1 here. This would simply be y there. Okay? There's nothing wrong if you do write y to the power of 1. But we don't need to write the power of 1 there. So in that case, we just simply get y. That gives us the solution there to B. And then finally here for C, we're asked to simplify 3z squared all to the power of 3. I've got 3z squared all to the power of 3 here. So in this case here, what I've got is a power raised to another power. If you think about this in total, what I've actually got here is 3z squared times 3z squared times 3z squared. Okay. So to begin with here, 3 times 3 times 3, in other words, 3 cubed, that would give us 27. We're going to get 27 here. And then I've got z squared times z squared times z squared. Because they all share the same base here, remember, we're just simply adding the powers. But you can also think about that rule then of power to another power here. We just multiply the powers together. So in that case here, we're going to get 27z. And that will be to the power of 6 there. Okay. And there we have it. So that's the solution to C there. That gives the solution to question 1. Moving on to question 2 now. So again, we've got 3 parts here. So let's begin with part A. We're asked to simplify a to the power of 0. So a to the power of 0 here. Nice and straightforward. Just remember that anything to the power of 0 here is simply 1. So in that case then, even though this is a letter here, it's a to the power of 0. That doesn't matter. It would still give us 1. That's the solution there to A. Moving on to B now. That's to simplify here. So I've got y to the power of 5 times y. And that's all over y cubed times y squared. So y cubed times y squared. So we start with the numerator here. Y to the power of 5 times y. We don't write but this y here. We have a little power of 1. And because they share the same base here, we simply add the powers. In that case, I'm going to get y to the power of 5 plus 1. And this will all be over y cubed times y squared. So again, they share the same base here. I simply add the powers together. That can be y to the power of 3 plus 2. And if we simplify here, y to the power of 5 plus 1, that would give me y to the power of 6. Doing the same here now with the denominator here, y to the power of 3 plus 2, that would give me y to the power of 5. And in this case here now, because we're now dividing, and we share the same base here, just using the laws of indices, we now subtract the powers. This would be y to the power of 6 minus 5. And in this case, we're going to get y to the power of 1. And again, we don't need to write the 1 here, so that would simply be y there. Okay? And there we have it. So that's the solution there to B. And then finally here, c. We're asked to simplify c to the power of 5. And that's all raised to the power of 3. So again, you can think about this here as multiplication. So what I've got here is c to the power of 5 times c to the power of 5 times c to the power of 5. That's what this multiplication here is stating, or this bracket here with this power raised to another power. That's what that's stating. But we can also use the rule of indices here where we've got a power raised to another power and we just multiply the powers together. So in this case here, we get c to the power of 5 times 3, which is equal to c to the power of 15 there. Okay, and there we have it. So that would be the solution there to c and the solution to question 2. So we take a look here at question 3. We've got 2 parts, so let's begin with part A. So for part A, we're asked to express 4 to the power of 9 times 4 to the power of minus 2 all over 4 squared as a power of 4. So to begin with here, what I'm going to do is I'm just going to write down this expression here. And this all over 4 squared, like so. So like we said, all we want to do here is express this here as a power of 4. So where do we begin? Well, the very first thing that I need to do here is simplify the numerator. So because they share the same base here, and we're timesing them together, then we'd simply add the powers using the laws of indices. This would be 4 to the power of 9 plus minus 2. This power here is 9, this power here is minus 2, so we add those together. And this will all be over 4 squared. So now we need to deal with this power here. So 9 plus minus 2, that's just the same as 9 minus 2. In that case, we're going to get 4 to the power of 7. And that's all over 4 to the power of 2, or 4 squared. So what we need to do now is simplify this expression here. So because we're dividing, and we have the same base here, and in this case, using the laws of indices again, we now subtract the powers. We're going to get 4 to the power of 7 minus 2. So 7 minus 2 would give us 5. What we get here then is a power of 4 is 4 to the power of 5. Okay, and there we have it. So that's the solution there to A. So we move on to B now. Like you can see, it's pretty similar. So all I want to do here is write down the value of 5 to the power of 5 times 5 to the power of 3 all over 5 to the power of 5. So again, I'm just going to begin here by writing down this expression. So 5 to the power of 5 times 5 to the power of 3. I'm going to divide this here by 5 to the power of 5. Okay. So again, to begin with here, what we need to do is simplify the numerator. So again, we have the same base here. So all I'm going to do here now is add the powers together. This would be 5 to the power of 5 plus 3. And this will all be over 5 to the power of 5. In this case here then, if we simplify this power here, 5 plus 3 is 8. We get 5 to the power of 8. And that's all over 5 to the power of 5. And again, all we need to do here now is simplify. So because we've got the same base again, we just simply subtract the powers because we're dividing. I'm going to get 5 to the power of 8 minus 5 here. In that case, we're going to get 5 to the power of 3, or in other words, 5 cubed. So we want to write down the value here. So don't leave your answer like this. We need to evaluate this here. So 5 cubed is the same as 5 times 5 times 5 again. And 5 times 5 would be 25. Times that by 5. And what we get here is 125. Okay. And there we have it. So that's the solution there to B and the solution to question 3. And finally, let's take a look here at the very last question, question 4. So again, we've got 2 parts. So let's begin with part A. So we're given that 3 to the power of 3, or 3 cubed, times 3 to the power of 5 is equal to 3 to the power of n times 3 squared. And we're asked to find the value of n. So all I'm going to do here to begin with is just write down this equation. We've got 3 cubed times 3 to the power of 5. And that's equal to 3 to the power of n times 3 squared. What we need to do here to begin with is simplify the left-hand side. So in this case here, because we've got the same base, both have a base of 3, then using the laws of indices here, we'd simply add the powers together. We're going to get 3, power of 3 plus 5. In that case then, this would be 3 to the power of 8. So therefore what we've got here now, do it underneath, we've got 3 to the power of 8, and that's equal to 3 to the power of n times 3 squared. Okay. So now if we use the laws of indices here again on the right hand side now, because they've got the same base, we can simply add the powers together. I get 3 to the power of 8 is equal to 3 to the power of n plus 2. Okay. Now, this might sound rather obvious, but these should be equal in value. Okay, that's what this equal sign tells us. So the left hand side is equal in value to the right hand side. But for these to be equal in value, then the powers must be equal here as well. Okay, because they have the same base. So in that case then, 8 is equal to n plus 2. So in that case then, if we just solve this equation here by subtracting 2 off both sides, we get that n equals 6 there. Okay, and that should seem quite obvious now when we kind of reflect back on the question here. So 3 to the power of 6 times 3 to the power of 2, 6 plus 2 would give you 8 there as well. Okay, so when you kind of look back at it, it seems quite obvious, but that's the way that we kind of deconstruct that question there. That's part A done. Let's take a look now at part B here. Let's just box this off just so we don't confuse ourselves. So we're asked to find the value of x such that m to the power of x to the power of 4 is equal to m to the power of 8. So again, what I'm going to do here to begin with is just write down this equation. I've got m to the power of x, and that's all raised to the power of 4, and that's equal to m to the power of 8. So what I'm doing here is I'm using the laws of indices again. We've got a power raised to another power. Remember, we simply multiply those together. In that case then, if we simplify the left hand side, we get m to the power of 4 times x, which is 4x. And that should be equal to m to the power of 8. Now again, it should sound pretty obvious, but these should be equal in value now by the equal sign here. So in that case then, because they've got the same base, all that can be left here now is the powers being equal. So in that case then, 4x is equal to 8. In that case now, we solve for x here. We divide both sides by 4. So 4x divided by 4 would give us x. And 8 divided by 4 would give us 2 there. Okay. And there we have it. So that's the solution to A. And that's the solution to B. And that gives the solution there to the very last question, question 4. And that brings the end of this video on exam revision for indices. In the next video, we're going to take a look at the highest common factor.